Good afternoon, ladies and gentlemen. And my name is Ricardo del Valle. I work as an innovation consultant in Bax & Company in Barcelona, and it's a pleasure to be here and moderate this panel discussion. The title of our discussion today is Circularity Meets Lightweight Design for the Future of Automotive. And as you may already know, lightweighting strategies have proved to be effective in reducing the weight of internal combustion cars. However, the transition to electromobility requires an even greater commitment. Electric vehicles are anticipated to make up to 75% of new car registrations in Europe by 2030, driven by the phase-out regulations of ICE cars in major markets. However, it's crucial to note that EV manufacturing currently results in 80% higher CO2 equivalent emissions compared to the production of internal combustion cars. Therefore, EV production is the main phase in the life cycle that emits CO2 emissions, but also the one with the highest reduction potential. Circularity strategies have arisen across the entire value chain to decrease the environmental impact of EV manufacturing. However, there are several challenges remaining. How can the European automotive industry address the circularity challenges while keeping the pace on improving lightweight performance? Welcome to our panel forum, where the experts from the European Lightweight Cluster Alliance, ELCA, will discuss the challenges and trends in automotive circularity together with the innovations that are needed to improve lightweight performance. Now, please, let's just welcome our panel of experts, starting with Violeta Vargas from Eurecat from Spain. Welcome, Violeta. Please welcome as well Thomas Hipke from Fraunhofer IWU in Germany. Thierry Renaud from Forvia, France. Stefan Cava from EDAG, Germany. And Professor Ahmed El Marakvi from the University of Northumbria, United Kingdom. Thank you all for being here today. Welcome, everyone. And, well, as we said before, we are here to discuss how circularity meets lightweight design in the future of automotive. These two topics are key for the European Lightweight Cluster Alliance. The ELCA network is the largest pan-European alliance working on lightweight and seeks to promote European lightweight around the globe. And, of course, these two topics are very important. The ZEBRA project actually aims to tackle the most important challenges that are currently faced in circularity and was incubated in the ELCA network and is currently coordinated by Fraunhofer. Thomas, can you please tell us a bit more about the ZEBRA project?
Well, I can do that. I hope you see some slides. Yes, now. The main goal of the project is to develop a car which 0% virgin material, 0%, except batteries and drives and cables. But the rest of the car, we will focus on this project. And clear we do that with using a lot of recycling material, but also shredding of components and take the powder, and also remanufacturing of parts. And we will do 8 use cases where we show how we can produce it in real state. And next slide, please. We are a lot of partners all over Europe, 28 partners, 5 OEMs, beside Skoda, which gives us a car where we can change the parts, Fiat, Stellantis, Volkswagen, and Toyota Europe. It's a very intensive cooperation just now. We have started with the project, and in 3 years we can show some results.
Thank you very much, Thomas. Now I will say a few words before we start the panel discussion, so how we're going to structure the session. I have here a few questions regarding the main challenges currently faced by the automotive industry. We have here experts that will share their views on the main solutions. Probably the one that we can start with is measuring circularity is a more complex process than measuring linear economy. And there seem to be different ways to do it. Violeta, what can you tell us? How can automotive do it in a harmonized way?
Yeah, it's true. It's more complex than linear economy. And also, it's true that there are so many ways of calculating the circularity of products, processes, and services that we can't focus on one, having so many options on different methodologies, different approaches. So the first thing would be to harmonize it, to have one standardized methodology to apply to all processes that we can follow in a harmonized way. But this requires lots of things, like requires compromise. It requires all the partners, all the value chain working together towards the same goal. And for this, then the goal would be to standardize the KPIs of circularity. Like, what are we going to measure, first of all? Is it recycling materials? Is it recycled content? Is it end of life, different solutions? What's going to be the KPIs that we're going to first measure? Then how are we going to measure them? And for this measurement, we should always follow the life cycle assessment, which includes all the life cycle stages of the vehicle. In this case, we're talking about vehicles, but it could be applied. This standardized methodology or method for circularity assessment could be applied to any product. But as long as we can continue considering all the life cycle stages of the product, so we can be sure that we are not moving the environmental impacts to another life cycle stage, as we've been doing in the linear economy. We've been pushing it all the impacts are going to the end of life of the product. So to ensure that we don't do that anymore, we have to include all the life cycle stages. So I think that would be like the first things would be to define the KPIs, then standardize a method to calculate these KPIs, and follow this life cycle perspective for the assessment.
And what do you think about the social aspect? The European Commission is pushing towards including these type of aspects alongside or within the circularity approach. What do you think?
Definitely. I was saying life cycle assessment as an approach because we continue talking about the environmental impacts, first of all, but we should consider not only life cycle environmental impacts, also the economic impacts and the social impacts as well, and the circularity KPIs that would be more involved into energy efficiency, recycling or recycled content, and all this. All these aspects should be accounted for in any study from the design of any product. In our case, from automotive industry, should be embedded in the design, the circularity, the social aspects, economic aspects, and environmental impacts as well.
You're mentioning design for circularity. I know the University of Northumbria, you're quite experienced in that topic. What can you tell us? How can that actually be the approach in automotive?
Yes, design for circularity, it's a very important aspect at the moment because it's specifically that safe and sustainable design framework which we need to integrate on it. So we have several factors we need to consider when we consider for circularity and when you consider about design. So first we need to implement an eco-design strategy or circular design strategy including all design principles. And these principles including end-of-life, life cycle analysis, design for X, like for example, assembly, de-assembly, recycling, reuse. And also for the material selections, we need to consider the material which could be recycled easily, de-assembled, like biodegradable material, renewable material, and so on. And also we could consider the modular design, which we can actually, the people could replace one specific component than replacing the whole products, which is much easier to replace. And long-time lifespan for the products as well. When we design for it, we need to consider the long-term durability, encourage for reliability. We can repair, we can repatch instead of just making a new device. And also for end-of-life parts, we need to consider from the raw material, from starting points to the end of use, and also for the recycling, so the full value chain. And the main important part is we need to implement the integration of SSB design, the new framework, which came in mind in December 2022. And this is make it a little bit challenges because the sustainability of chemical and material, it might causing issues in the whole supply chain when you consider for recyclability. And the main important part, the old products, which is circular design, need to be affordable at the end, because otherwise it would be very expensive.
Yeah, you're touching a very important part, that indeed these products that are designed for circularity should also be affordable, otherwise industry cannot take them. But we see that this is not true in many cases, and actually many circular products can be more expensive. Thomas, how do you think we should address this issue of affordability?
Well, in general, I think we should not always speak over recycling. Recycling technology is mostly also expensive, and to recreate and the new part is expensive. That's why also in this project they think about remanufacturing. It's always good to reuse parts or remanufacture parts. In this case, we take a car roof and make from that, we make a door. And in the formerly projects we have shown it's possible. We have brake disc covers or parts of a chair, easy parts, I would say. Now in this project we take a high-class component and make a high-class component. This is the effort in the project. And when we reach that, then we save costs, we save environmental impact. And this is one solution what we have to do in future. Not only speak over recycling, recycling is famous, but starting with reuse and remanufacturing as a next.
From the side, Thierry, you work with thermoplastics. What will be then the approach for the part of metals remanufacturing? What can you tell us about the affordability?
Yes, my answer will focus mainly on composites, and it's a composite show. That's good. Yes, the topic of the cost of recycled material, first of all, for composite, how to recycle the material. Big difference between thermoset and thermoplastic. The technologies to recycle thermoset today are indeed quite expensive, difficult to make. You need to separate the fiber from the resin, so that has a cost. It makes sense today if you have a part which is made out of carbon fiber, but how to do that with glass fiber is still very much an open issue. So my company, today we focus mainly on thermoset, so we are really dealing with that, and but we also work on thermoplastic, and we think that thermoplastic somehow would be a little easier, a little cheaper to recycle, due to the fact that you can mechanically recycle them, which is a process which is more short-term and more easily available.
Thank you. And Stefan, what do you think about the part of affordability, this challenge? How can that be approached of automotive companies?
Yeah, I think we should separate this a bit into two different types of vehicles. For the usual passenger vehicles, which are sold to the end customer, then the price you pay for the vehicle is very decisive. But if you see, as an example, a commercial vehicle or a light commercial vehicle, then the customer sees the entire lifespan. And if you could possibly incorporate more or longer lifespan and make it more sustainable by making it recyclable, then you can really achieve better business models. That's what we could see. We already presented a few concepts for that, and we could see that we reached more or less the break even in terms of cost and way better in terms of sustainability. And then I think the problem is not that huge anymore, but I still see it a little bit for the standard passenger vehicles. If you really go down to cost only, then there's still an issue given. That's for sure, yeah.
So we were mentioning before this challenge of affordability. One solution is, of course, the use of recycled materials. We have mentioned remanufacturing, the other type of approach. But how can we ensure, actually, if the approach to improve affordability is through the use of recycled materials, how can we ensure that there is actually a supply of recycled material that is stable, that is easily accessible to automotive companies? Thierry, what do you think about that?
I think that's one of the big problem we are facing, at least short term today. Yeah, it's very difficult to have a match between, okay, you have a source of a recycled material, you have a need. How do you have this at the same time with the same amount? with the right quality. So today I think technically a lot of things are possible. So the question of the supply chain is really key here. Well, we see a lot of initiative. We see a lot of startups developing the new technologies for recycling. What I see also as a positive sign is we see also the bigger players, the company who are more involved in dealing with waste in general. It's quite new. We see interest from them to say, oh yes, there are these. I'm focusing again on composite. There is these sources of composite. Okay, what we have in mind is that they are not recyclable, but okay, you still and only these big players, I think, or not only these big players, but these big players have a role to play because exactly what I was saying at the beginning, to have a match between the amount available, the amount that you need. You really need to create a network, and it's not just one source and one customer. So you need to have multiple sources, multiple customers, because if everything is linear, then if something breaks, then the whole chain is broken. So it is starting. Is it available today? Not yet. But well, already this morning I had a few companies who came to our booth to say, yes, I have this process, maybe you can use it. So I see things moving, and the project, Zebra project, will be a great project to work on that.
Great. Thomas, you want to add something?
To have enough material for recycling will be a challenge of the future. And some companies think about that business models that they not sell the components, that they only rent the components, because then they are still the owner of the material. Would be interesting for the future. But what I want to say also for that is we want to show in this project one example where we use an old aluminum foam part, we shred it, and with that material we create a new part. From this powder, we go not to the remelting, we use the powder, have a blowing agent again, and take with the same material a new part. Well, this we want to show that it's possible for the future.
I think you were more mentioning exactly what Violeta mentioned at the beginning, this part of the network, how there needs to be an interaction between all the suppliers, the part of the recyclability of materials. Violeta, what can you tell us about it?
I was about to say that I think we're back to collaboration. This is the key here, is collaboration between all the actors in the value chain. Otherwise, this doesn't happen. It's just everybody collaborating towards the same goal. This is the main goal for everybody. But yeah, I think there's a need for long-term relationships also in the recycling part, so that we can have enough material to introduce in the system. But this requires collaboration again, is the key here. Also, I think most important in this, to provoke this change, is for the industry also to include in the design of new automobiles, in the new design of everything, that the recycled content is already embedded in the design. So this will push the markets and the recycling facilities to have more quality in the recycled material that they're recycling. But again, it's a collaboration with all the actors, because on the one hand, we have the industry that can improve the design from the beginning, including the recycled content in all the materials, in all the parts. But then we need also a standardized method to calculate the circularity, so we can measure it and make it available to all the audience, to all the actors. Also, transparency in this data is important, because we need quality in these materials, and we need to know where it comes from, where it can be applied. So again, this is collaboration, but it's a lot of hard work from all the value chain actors. Yeah, I think that's the key.
Yeah, Violet, I think you mentioned data and you mentioned the use of recycled materials. Ahmed, what do you think about the relationship between these data, recycled materials, the manufacturing technologies?
Yeah, and just a comment for Terry and Thomas. For the quality for the recycled material, we need to make sure that we're using the most advanced recycling technology, like chemical recycling, and also technique for sorting the material to make sure the quality and yield of the composite material, for example. And also, as Thomas mentioned about upgrading the recycled material by say, upcycling, taking lower value material for to upgrade to higher value material specifically for high performance automotive application. But one important part also for the certificate and standards, because we need to have standardization wide range from the industry to make sure that this recycled material had the quality, the high performance application, and also the quantity, not just the quality and the quantity needed for that. And the most important part, again, all this recycled material need to be processed for the manufacturing technology.
And are the manufacturing technologies actually optimized to
Yes.
recycle materials?
There is a lot of manufacturing process now undergoing to consider recycled material, like 3D printing, for example. Now they're using recycled metal and plastics. The major part is to enhance the production rate, reducing the scrap and waste, and also to enhance the energy efficiency. Closed loop, it's very important also to make sure that the material sense of the raw material and use, reuse, and reusing for the new applications need to be closed. For the manufacturing process, also there is a lot of digital technology adopted, like AI or industrial Internet of Things, to enhance the manufacturing processes as well.
And Thierry, also from on your side on manufacturing, how are you approaching this, the optimization of technologies to uptake the recycled materials? Is this something that at Forvia you are also optimizing?
Yes. Well, in different areas we are working on recycled materials, and for plastic parts, for interior parts, in my activity for composite as well. So of course I think I like the idea of upcycling. I think we don't always have to think recycled material is less properties. In some cases we can actually take a recycled material and make it better through additives, through addition of fibers or so on, and create some new opportunities and some new materials that can be attractive, and that okay, we are pushed to do it now, and so it's creating also new opportunities and new.
Okay. Well, we talk about, of course, using recycled materials to reduce the costs, process them with innovative technologies, but how can we ensure that actually the end-of-life vehicles are efficiently recovered for recycling? Stefan?
This is really a tough thing to do, because today the vehicles are being sold and sold again, and usually they're going to the east or to the south, and you do not have them there where you sold them. This is hard to overcome. There are first companies, first OEMs starting plants where they are buying back vehicles to recover the materials, but I think this can only be working for, let's say, 50% of the vehicles, because most of them are just not there anymore. But I don't think this is an excuse for not doing anything. I think if a better recyclability is given and you give a value to the vehicle and also to the single parts of the vehicle, then the people are willing to sell them back after numerous phases of using it. This were from the one hand, and also if you are starting maybe with fleet vehicles like post vehicles, taxis, buses, delivery vans, etc., and they are really create a vehicle purposed for being reused or recovery of materials, remanufacturing, etc., all the different methods of circularity, then we start setting up an ecosystem. And if we have once this ecosystem, this can be expanded also to smaller vehicles, different vehicles, and I think that's the way to establish such a supply chain, and at the end to get back the parts, to get back the material, to get back components, and to have a profitable business. on circularity with all the different actors. Because today I think there are numerous steps to be made, but there is no incentive for that. The one partner, possible partner, says I have no incentive to do that because nobody's buying this. Nobody's taking up what I do. And we must start somewhere, and I think using this for fleet vehicles, starting with fleet vehicles, then expanding this is a good idea.
This part of the reverse logistics that you're mentioning, the integration of recycled materials into new components, is a core part of this new end-of-life vehicles directive. This is now a big topic with companies, as this is a new directive that is coming. Thierry, what can you tell us about this new directive? What is the approach that you are taking from Frobia?
So maybe a few words about the directive. Of course, I will not be able to explain everything because it's a fairly heavy document. But let's say the idea of I think the Europe is to go towards circularity. So to do that, a new directive, is in discussion. So it's almost voted, but it's still in discussion since last July. The key points are really pushing the market towards circularity. So thinking when you design a car in terms of eco-design, how will you recycle it? So OEMs will now have to demonstrate that the car is really recyclable. To what level? And then what directly impacts us as suppliers is some mandatory amount of recycled content within the parts, especially for the polymer parts. So there is a value of 25% of all the polymer parts of the car that should be from post-consumer recycled material, including 25% coming from the car itself. So that means some of the material can come from other sources, can be packaging, can be whatever area, but 25% of this 25% should come from the car, from another side car. And today, this is really not the case. We are using recycled material, but in most cases, in cars, the recycled material is post-industrial. And Europe is really pushing us to use now post-consumer recycle. So that means to create all this network and going towards circularity. So this is indeed a very, very important directive with a lot of impact on our daily business, yes.
Ricardo, I think we will have changing in mind in future. We will have a growing disassembly industry. I believe 10, 15 years we will have, beside of the assembly factory for cars, we have also a disassembly factory of cars. It's necessary. It makes no sense to shred all the plastic parts and then to sort out with complicated and not successful technologies in the moment the right plastic content to the recycling process. We need a controlled disassembling process so that we know which material we have and giving to the right recycling process. And this takes time, and it's open who will do that. But I'm sure there will be companies growing in this field in the next years.
Also, sorry. Also, before you said also about reuse. So this disassembly facilities will help to go to a previous stage before reaching recycling, reuse first, or repurpose, or whatever before reaching recycling. But yeah, I agree. It's great.
I just want to add the point, this will also lead to a reduction of the variances you have in a vehicle. Today you have, 80, 100 different kind of plastics, and I think we should reduce this. Maybe achieving the functions with just different design, not really with a different material. And otherwise I think it's all about sorting at the end, which is more or less impossible. But what's the value of having 80 or 100 different piles of plastics by not having just 20? And also the industry is switching towards giving larger components or systems to suppliers, and I think we will end up at really having just one or two materials in a larger part, a larger component, to make it at the end much better recyclable. And that's, I think, the way that will be followed. And but there's still a very long way to go. If you see where we are today, and achieving this 25% of old vehicles, where I just do not see any today, is really a long way to go. But we are engineers. That's why we are here. That's our job, yeah? And I think it's possible at the end.
Violeta, please go ahead.
Also, I just wanted to add that I think this is also going to be very strongly linked to the product passport as well, because having the product passport will help to identify what you have in the vehicle or part that you are disassembling at the end, right?
All of you have mentioned different topics, how the use of recycled materials and the affordability and how we need to change the supply chains. Thomas mentioned as well how this disassembly. Do you think there are knowledge gaps nowadays in terms of how is industry can be prepared for actually be ready for all these changes?
Me?
Please,
Okay.
Stefan, please.
Yeah, definitely. I think if you start, if you're coming from university at the first thing, let's more or less talk about composites now. You start with design for metals, then you have to learn to design plastics, then you have to learn to design composites, to learn anisotropy, etc. And now you have to add the aspect of recycling and all the different aspects. And I think it's becoming more and more complex. And I think we need more education on that, training on the job. That's very important, I think, because if you're leaving university, then you still have 40 years with numerous changes, and I think most of us are not prepared for circularity today. And I also say I personally do not know everything about recycling and reuse yet. And so training on the job is really important. Continuous training, improvements of design must be taught, and I think you cannot learn enough on this. And this is going to be a very important value in future, to learn how circular design looks like, how sustainable design looks like. We're starting this in our company. We are training more and more people. We have our own courses about circularity and sustainability, but it will take numerous months and maybe years to cover all the people who possibly need this course, because it's a different way of designing and it's a more complex way.
Thierry, you wanted to add something as well?
Yeah, just wanted to say that yes, it's really a change the culture will have to change, because all I did since I started to work, it was trying to optimize, to integrate function, to make a product. Really, the idea about recycling was very, very low in the list of mandatory things. To be clear, so when you think about how will I disassemble the part, the car at the end of the life, that's a completely new approach, and a lot of things we have in mind. All our habits will have to be changed already. Very often we stack layers to make sure that they cannot be disassembled, because we want them to be the top quality for 15-20 years. So yes, I agree with training and also the world of, I think today the world of the recyclers is completely different from the world of the automotive manufacturers and the suppliers. So today, we are not trained. We don't know what is so easy to recycle. They don't know how we make the car. They just see at the end of the life the cars arriving, and so yes, there's a lot of training, cultural change to be done for circular economy.
Can I just
yes,
add
of course,
one,
please.
just to follow for the educational part? That's why for Zebra we have dedicated effort for the training and platform. So we're going to create a huge platform for education and training, and this including researchers and students from universities and also engineers from companies to have access to the platform to learn about the circularity, about the design, about the life cycle analysis, about the modular design. So this will give us like more comprehensive ideas for people. Also for the increasing the customer engagement, because as Stefan mentioned also, there is some issues about the customers itself when they're looking for the circular material. I don't know if they accepted if they know the cars has a lot of recycled material, so they need to be also trained to accept that the new products will be made of recycled material. Just one comment for Terry, when 25% came from the old car, I guess we are working now to increase this percentage. I know it's difficult, but to upcycling, so by adding small additives and different properties to have a functional material. And once you have the functional material, you can increase actually the amount of recycled material for a different application with high performance. So if we follow this approach, actually we can increase the amount of non-used material from the car, so we can increase into 25%, hopefully.
Thank you all for the comments. We're almost approaching the end of the panel discussion. There's going to be a Q&A part where everyone from the audience we will still have some time to make some questions to our experts. But before going to that part, I would like to maybe just ask one question that maybe each of you can tell us what could be, in your opinion, from your organization, the main challenge that is currently faced by automotive circularity, and how your organization is contributing to a solution. So I would like to hear from you. We'll still have around 3-4 minutes, so I will ask you to be a bit brief, but to cover all of you. So maybe starting with you, Violeta.
I think the harmonized methodology is the greatest challenge that we have right now. We need regulation, we need support on standardized processing, processed methodology, and collaboration, again.
Well, in our institute, we have a lot of designers, and we design machine tools, cars, and so on. And in my point of view, it's the most important thing for us to focus on design for recycling, design for reuse. We have to start at this phase that we have not the big problems in recycling at the end. And this is our challenge in the institute.
On our side, we have a lot of challenges related to the materials. So actually, we are getting more and more involved in the development of materials that we were not doing. We were mainly relying on suppliers, but we decided to enter into the kitchen, as we say, because yes, this development of sustainable material, integration of recycled material. We didn't talk today about biosource material, but that's also a topic. So that gives us some new opportunities to work on development of new materials that are not on the market, and so that's how we work with it.
I have a similar opinion as Thomas says, but I want to add one more point. Dealing with the variability of materials, because you never exactly know the properties. You have changing properties, changing due to temperature, whatever, but now also due to where the source is, what's the source of it. It's going to be a big challenge to simulate, to test, and at the end to validate it. That's going to be a major topic for us.
At the university, we are following Thierry's path, because we are always building new material, and the material is a smart or non-reinforced material with specific functionality. So all people talking about the composite metal recycling, but not too much about smart material or more advanced material to be developed. So the idea here is if you have a graphene or non-reinforcement to enhance the composite functionality, this is the major problem was recycling this part. So this is our focus at the university at the moment.
Great. Great to hear. I think now we can go to a Q&A part of we still have some minutes. I believe, if I'm not wrong, I think we have 10 minutes for questions. So please, what I will ask is that you can just raise your hand. Someone will pass you the mic. And if you just can say your name, your organization, and one of the experts will try to answer your question. I think there's one there.
Hello, it's Martin Wakeman from EPFL. Love the discussion. What role could blockchain have in your disassembly factory of the future?
Should I maybe? Yeah. We were working on a project with a very digitalized solution in the last 4 years. It's called DigiPrime, where we developed an online platform where the blockchain technology is used to more or less to track all the parts which are coming back from used vehicles to go to remanufacturing and back. And this proved to be a very good solution. But yeah, you really have to start tracking in the workshop. In the workshop where you're really covering the cores, and then you're bringing them through numerous stages of remanufacturing, upcycling maybe, upgrading possibly, and then bringing back. So in this project, we had very good experience with that. But honestly, I don't think this is working too well if you have one material, because the material is then at the end a mixture, and blockchain is usually used to cover one part, maybe. So depending on the way you define the reuse or the circularity, so it works better for the, let's say, higher levels of circularity. If you go down to the lower levels like recycling, which is more or less one of the last levels you're reaching, then it's maybe not a good idea, but for the higher levels it's a perfect solution. And in combination with these product passports, that's I think the way we should follow.
Violeta, would you like to add something?
You already mentioned it. It's related to the product passports, and we're also working in other projects with blockchain as well. The project is called Recirculate, but we still haven't applied it. We are on it, but yeah.
Okay, thank you both for your answers. Any other questions? We have one more question, yes?
Good afternoon. This is Nicola Bucchioni from the company Ube. We are a polyamide, a nylon producer. We produce nylon, virgin, and we recycle nylon. In our experience, only post-industrial recycling can guarantee certain level of the quality. So I would like to ask you how much of your projects is based on post-consumer recycling and how much presently is based on post-industrial recycling, because as nylon producer of a material, an highly engineered material, post-consumer is not good enough. So I would be curious to know some percentage and some vision in this sense. Thank you.
I think I will have to answer because most of the project is about steel and aluminium and glazings and others. So, well, on our side, we are trying as much as possible to use post-consumer recycle. We don't rule out completely the post-industrial. There's one material where we are working. We have been working already quite a lot is PET, where we are using about 80% of recycled post-consumer material. With polyamide, I don't know. We have not tried yet.
For metals, I can say we have only post-consumer materials, but there's much more easier than here. And with alloying of the melt, you can arrange the right alloy to root alloys or casting and so on.
And for me, I'm also saying I don't know of any polyamide post-consumer projects yet, but we know the directive, we know what we are heading for, and now you have the time and we all have the time to be prepared for that, because it's definitely coming at the end. At the end we will have this because we want to reach a circular economy. Maybe it will take some more time, maybe it will be coming faster than we expect, but we should prepare technologies and maybe prepare at first our minds for that, yeah.
Thank you for the answers, and thank you for the question as well. We have more time for more questions. Any other question from the audience? We have, yes.
Yeah. Hi, everybody. My name is Matthew Corey. I'm a scientist at Oak Ridge National Lab in Knoxville, Tennessee, in the United States. Thank you so much. This has been a really interesting panel to hear. I just wanted to follow up to the last question that was asked, because I think it's a valid one. I wanted to ask, not every plastic in a vehicle sees the same lifetime. There could be some plastics that are under the hood, inside of the vehicle. Ford now has a cross carbine that's entirely injection molded one part all the way across IP carrier. And so I think that those kinds of materials, if they're not necessarily exposed to UV, maybe they're not seeing quite as much temperature like a battery box would. Are there any components that you think might counteract, the claim that these plastics just simply can't perform? Are there some that you think could be maybe recovered and recycled and still meet performance?
Thank you. No, that's a valid point. Actually, I'm with Stefan here. So actually, we have to find solution, because that's really the trend. Is we need to reuse the materials coming from the car and from everywhere else. So the objective for cars is 25% of 25%. So that's 6%. So that leaves a lot of room for what you're mentioning. Out of 100% of the parts that are in a car, today the objective would be to reuse 6%. Which are these parts today? Well, I think it would be, yes, probably easier for the polypropylene part, I would think. But my side, I'm more focusing on composites, so adding continuous fibers or very long fibers in the material. So that's my perspective. So I'm not a very big specialist for the purely plastic parts. So sorry about that.
From my perspective, I think at least we should start at those parts which are simple. Taking those parts which are not under the hood, maybe not at higher temperatures, not under UV, but maybe some invisible parts, gray zone parts, etc., and produce new gray zone parts again. Because this directive is not covering one single part, it's covering the entire vehicle. And you can have 100% recycled parts, a few of them in maybe less demanding applications, saving the rate. And that's where you start. But on the other hand, keep in mind, this is the rate for now, which is set today, but there will be a higher rate later on, probably. And we should start doing it and expanding this. And whatever you do in this direction, it's definitely not wrong. It's maybe too early. But at the end, if you want to sell vehicles or parts for vehicles, it's a good idea to include more recyclates, and the customers will probably buy it. Maybe not today, but maybe in a few years. And that's, I think, the way we should follow.
Thank you very much for the answer. I believe we might have time just for one more question. Is there any more questions from the audience? Okay.
Thank you for the talk. Hannah Swinburne from the National Composites Centre in the UK. I know a lot of people use circularity to mean different types of materials. Where do natural fibres and biocomposites fit into circularity to you? And is there a space for things like composting for low-grade or very damaged parts?
Can I answer this?
Yeah.
Well, we have a new project gonna start very soon about the bio-based composite material. And for those biocomposite, it's mainly to develop the biocomposite made of 95% at least from the organic parts. And we have using natural fibers, damaged fibers, and also synthetic lignin-based fibers to consider the cradle-to-cradle approach for the proposal. The project will start very soon, in 3 months, but we haven't tried yet. So hopefully maybe the next year we'll give you some more dedicated answer for that. But we're using damaged carbon fibers, and within the 5%, because it's mainly to have 95% bio-based, but the rest is the natural or lignin-based carbon fiber. Thank you.
I want to add, natural fibers are very interesting, it's clear, but for this European call, it was said that we have to use 0% virgin material. In this case, it's also natural fiber, virgin material, but it's interesting for sustainability in general. That's why it's not included.
I want to add, if you do it like you mentioned, if you have at least a very high percentage of really bio-based content, then it really makes sense. If you do it like in many cases, you combine it with a matrix, which is a standard matrix. Honestly, I don't really believe too much into natural fiber composites then, because I do not really see the, let's say, the benefits. But where I really see benefits is reusing old used fibers, recovered fibers, particularly carbon fibers, because they still have a high value. And because then it's some kind of upcycling, or at least keeping in the circle of them. And up to now, we only had good results for that. It's clear that it's not a very high performance which you can reach, because if you cut the fiber, it's cut. You cannot recombine this again. But you can still keep it in well-performing areas, and that's where I see the points to work on. On the one hand, 100% or almost 100% bio-based content, which at the end means you can burn the part and you did not do too much harm to nature. And on the other hand, recycled parts, recycled fibers, maybe also recycled resins in a perspective. And these are the solutions that really lead to more sustainability, circularity, etc.
But the challenge we have that the 95% of bio-based comps, it must have a high performance application. So this is the main challenge. That's why the European Commission asked for 5% non-bio-based. So with those 5%, we can add in more flexibility of additives or anything to increase actually the higher performance. And this is the main challenge for that project.
Yeah, but these 5% are very good value compared to what we have today. Yeah.
Thank you very much for the answer. I would like to just to announce to all our audience that our experts will be here at the Meet of Sound, where if you have more questions or you want to get in touch with them, we were going to be there. Unfortunately, we are running out of time, so we need to close now the session. Thanks to all our experts and all the audience for your attention. I would like to ask for an applause for our experts.
Thank you.
And I believe several challenges were discussed, from affordability to the use of recycled materials, knowledge gaps, and there's still some way to go, but definitely we are on the right track, and I believe from industry and academia, they are working both in different solutions. So thanks everyone for your attention, and yeah, have a nice rest of the day. Thanks.
Thank you.
Thank you.